All right, pre-calc guys, here we go. This is actually the last thing we're going to talk about. It's two things. It's looking at limits and then looking at derivatives. And for you guys, it was only derivatives with the power rule, so that's real easy. And then the limits we're going to look at are graphically. And then I'm just going to give you a simple limit where you just input a value. And that's what is on your test. So um, let's just go ahead and get started. A limit is a value as we approach an x value. It's an output. It's the y value. That's why it says f of x. As we approach a certain value on the x-axis, as x approaches, this says the limit of this function that is graphed here, as x approaches -3, and if there's something to the right of that value, that just means approaching from the left. The negative means it's approaching from the left. So as we look at -3 here on the x-axis, and we look at how we're approaching, what number are we approaching on the y-axis? Let's see if I can make this a little darker. It looks like we're approaching 1, right? So it's getting infinitely close to 1 on the y-axis. So its output would be 1. So we'd put a 1 here. And maybe I'll change the color, make it a little bit darker, easier for you to see. Let's try that guy. And then right down here it says, as we're approaching -3, from the right side, from the positive side. And so we just follow the graph down this way. Sorry about that arrow. And it also looks like we're approaching 1. So we'll make the 1 here. And this, if there's nothing to the right of that -3, just means approaching from both sides. So we look from the left and we look from the right, and it looks like we're approaching the same value from both the left and the right side. So if we are indeed approaching the same value from the left and the right, this entire limit does exist, and the limit is 1. Now, if we have this function and you see that it's empty here, it doesn't actually have an output of 1, but we're getting infinitely close. So we have almost an output of 1, but right at -3 here, if you put in a -3, you won't get an answer out. You'll get an undefined answer. And that's why we talk about limits. Let's get back to this side. We're going to look at 2 the same way. Right? So we go over here to 2, and this says, as we approach 2 from the left. Let's see if we can find something else. As we approach the 2 value from the left, from the negative side, looks like we're coming down pretty steep right here, and it looks like we're approaching an output of 2. Okay, so I'll put a 2 here. And what if we're approaching it from the right side? Well, if we're approaching it from the right side, it looks like we're getting infinitely close, and we actually reach the value of 1. Well, if we look from both sides, like this one says, we get 2 from the left and 1 from the right. So this actually, we would write does not exist. So you're going to have a couple of graphs like this where you're going to have to look as it approaches from the left and from the right. All right, so really and truly, that's the big idea of limits on a graph. Now you're also going to see limits. Let me jump down here. You're also going to see limits that look like this. You're going to say, what is the limit of f of x as x approaches, let's say, 3. And then you're going to get f of x. You know, could look like this, or it could just look like this, f of x. And now they're going to have to give you a function, right? So I'm going to say x cubed minus 2x squared plus 4. All right, and this is a cubic function. If we graphed it, it would look something like that, some way, shape, or form. But with this type of function, all we have to do is substitute in the 3 for x, and we would get out some sort of output value. So let's do the math. Let me change color and do the math. 3 cubed minus 2 times 3 squared plus 4. And 3 cubed is 27. Minus 9 times 2 is 18. Plus 4. So 27 minus 18 was that 9. And 9 plus 3 is 13. Seems about right. So we would say that the limit as x approaches 3 of this function is going to be equal to 13. And that's all you're going to have to do for limits. See how easy it is? I didn't give you any other types of limits that we had to worry about, limits to infinity or anything like that. It wasn't necessary. Let's go to the last piece. I think it's this one, yeah. Oh, I'm going to have some bleed, so I want to get rid of it. Let me hide this layer just for a second so I can get rid of this. Sorry about the time I just wasted. There we go. And back here. And we'll start working on this. So what's a derivative? A derivative is a way to find the tangent line to a curve. And that was just what we were touching on at the very end. It's what we start with when we get to calculus. We start with limits and then we work on all sorts of derivatives. This is the first type of derivative that we're going to take. It's what we consider the easiest of all the derivatives. And if you look at this formula, it just says if I have a function of x equals, let's say, x to the 5th power, right? That's my function. That's all it is. This says that the derivative in respect to x is the power times x, and then that power minus 1. That's how you take the derivative. We write it in a couple of different ways, but for my purposes here, we're going to say f prime of x is equal to, what's that power? That power is 5 times x to the 5 minus 1 power, which is just 5x to the 4th. Now, I didn't have to go through all of that mishmash. I think you guys could have figured that out pretty easily on your own. Let's do one more. Let's do one that has a couple of terms in it, and we'll do that to every single term. And I'm going to remind you that constants sort of disappear. So here's our new function. Function of x is equal to 2x cubed plus 3x squared minus 8x plus 6. All right? And we're going to use this power rule for each and every term that we see. So what we're going to do is we're going to do f prime of x, or the derivative of this function, excuse me, is 2 times 3x to the 3 minus 1, 3 times 2, because that's our power, x to the 2 minus 1, minus 8 times 1, because that's our power here. Our power is 1, and this is actually an x to the 0 power if you think about it. Because x to the 0 power is just 1, and then 1 times 6 would be 6. So getting back to this 8 times 1, x to the 1 minus 1, see that there, and then lastly it's 6 times 0 times x to the 0 minus 1, and we're going to see what happens. So 2 times 3 is 6, x, 3 minus 1 is 2. 3 times 2 again is 6. X to the 2 minus 1 is just x. And then minus 8 times 1 is 8. X to the 1 minus 1 is x to the 0 power, which is 1. And then here we go. This is why this constant goes away. It's 0 times x to the negative 1. It doesn't matter. It doesn't matter at all that this is an x to a negative power. It's being multiplied by 0, so that just goes away. So our real answer ends up, and we don't have to write x to the 0 power. Everybody understands that x to the 0 power equals 1. Anything to the 0 power equals 1, so 8 times 1 is 8. So the final answer should look like this: x squared plus 6x minus 8. And that's it, guys. That's what we need to know. So we would say f prime of x equals 6x squared plus 6x minus 8. That's it. This and the other video will help you get through the entire test. Have a great time taking the test, and please, please, please don't worry.